The moon, our celestial neighbor, is more than just a beautiful sight in the night sky. It plays a crucial role in maintaining the stability of Earth's systems. Its presence influences everything from the tides to the length of our days. Without the moon, Earth would be a vastly different planet. The moon's gravitational pull creates the tides we experience on Earth. This same gravitational force also helps to stabilize Earth's axial tilt, which is responsible for the seasons. The moon acts as a kind of anchor, preventing drastic shifts in Earth's rotation that could have catastrophic consequences for life. The moon's influence on Earth is a testament to the interconnectedness of our solar system. Even seemingly distant celestial bodies can have a profound impact on our planet. Understanding the moon's role is essential for appreciating the delicate balance that makes life on Earth possible. The Earth and the Moon are locked in a delicate gravitational dance, a cosmic ballet that has been ongoing for billions of years. The Moon orbits Earth, and this orbit is governed by the force of gravity, a fundamental force that pulls objects towards one another. This gravitational force pulls the Moon towards Earth, preventing it from flying off into space, while also influencing the ocean tides on our planet. However, the Moon also has its own momentum, a forward motion that keeps it from falling directly into Earth, creating a perfect balance. This balance between gravity and momentum results in a stable orbit, a harmonious relationship that has persisted for eons. The Moon travels around Earth in an elliptical path, completing one orbit approximately every 27.3 days, a journey that affects many aspects of life on Earth. During this time, the Moon also rotates on its own axis, and it does so at a rate that keeps the same side facing Earth, a phenomenon known as synchronous rotation. This synchronous rotation is not a coincidence, but rather a fascinating result of the gravitational interactions between Earth and the Moon. It is a result of tidal forces between Earth and the Moon, forces that have shaped both celestial bodies over time. These tidal forces have gradually slowed down the Moon's rotation over billions of years until it became tidally locked to Earth, always showing the same face to us. This delicate balance is essential for maintaining the stability of the Earth-Moon system, a system that has profound effects on our planet, from the tides to the length of our days. The Earth-Moon relationship is a testament to the intricate and delicate forces at play in our universe, a dance that continues to captivate and inspire us. What if, in a thought experiment, we imagine the unthinkable? The Moon suddenly stops orbiting Earth. This hypothetical scenario, while highly unlikely, allows us to explore the fundamental laws of physics and the interconnectedness of celestial mechanics. If the Moon were to suddenly halt its orbital motion, the primary force acting on it would be Earth's gravity. Without the counteracting force of its orbital momentum, the Moon would begin to fall towards Earth. This fall would not be a gentle descent, but a relentless plunge driven by the inexorable force of gravity. The consequences of such an event would be catastrophic, reshaping the Earth-Moon system as we know it. The delicate balance that has existed for billions of years would be shattered, leading to a cascade of events with unimaginable consequences for life on Earth. The Moon's descent towards Earth would be governed by Newton's law of universal gravitation, a fundamental principle that has shaped our understanding of the cosmos for centuries. This law states that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Essentially, this means that the gravitational pull between two objects depends on both their masses and the distance separating them. In simpler terms, the more massive an object, the stronger its gravitational pull. For instance, Earth, being significantly more massive than the Moon, exerts a much stronger gravitational force, and the closer two objects are, the stronger the gravitational force between them. This is why the gravitational pull between the Earth and the Moon is so significant despite the Moon's smaller mass. In the case of the Moon and Earth, the Moon's mass is significantly less than Earth's, but its proximity makes it a significant gravitational influence. The gravitational dance between these two celestial bodies has profound effects on our planet, including the creation of tides. As the Moon falls towards Earth, the distance between them decreases, causing the gravitational force to increase exponentially. This increasing force would not only accelerate the Moon's descent, but also amplify its impact on Earth's natural phenomena. This acceleration would cause the Moon to pick up speed at an alarming rate, transforming it from a celestial neighbor into a hurtling projectile on a collision course with Earth. The consequences of such an event would be catastrophic, altering the very fabric of life on our planet. The collision would unleash unimaginable energy, causing widespread destruction and potentially triggering mass extinctions. The delicate balance that sustains life on Earth would be irrevocably disrupted, reminding us of the immense power of gravitational forces. Imagine just for a moment the Moon suddenly halting its rotation. This seemingly simple change would unleash a cascade of devastating effects on our planet. The consequences would be nothing short of catastrophic. The Moon's rotation is intricately linked to many natural processes on Earth. Tidal forces, which are driven by the Moon's gravitational pull, would be thrown into chaos. The rhythmic rise and fall of ocean tides, which we often take for granted, would become erratic and unpredictable. Coastal regions would experience unprecedented flooding, with water levels surging far beyond their usual limits, inundating cities and towns, while other areas might see the sea levels drastically drop, exposing vast stretches of the seabed and disrupting marine ecosystems. But that's not all. The Moon's stabilizing effect on Earth's tilt would be disrupted, causing our planet to wobble on its axis. This wobble would lead to extreme and unpredictable climate changes. We could see more frequent and severe storms, droughts, and other weather anomalies. Seasons as we know them could cease to exist, replaced by erratic weather patterns that would challenge every form of life on our planet. The predictable cycle of spring, summer, fall, and winter would be thrown into disarray, replaced by erratic weather patterns that would challenge every form of life on our planet. Crops would struggle to grow, and ecosystems would be thrown out of balance. And let's not forget the impact on nocturnal wildlife. Many species rely on the Moon's consistent cycle for navigation and behavior. The sudden change would disrupt their natural rhythms. Many species rely on the Moon's consistent cycle for navigation and behavior. Birds, for instance, use the Moon to guide their migrations, while other animals depend on moonlight for hunting and mating. A sudden stop would disorient and endanger countless animals, potentially leading to widespread ecological imbalance. The delicate balance of predator and prey would be disrupted, potentially leading to widespread ecological imbalance. Endangered species could face even greater threats, and entire habitats could be thrown into chaos. In short, the Moon's rotation is a delicate balance that keeps our world in harmony. It influences everything from the tides to the stability of our climate and the behavior of wildlife. Any disruption to this balance could spell disaster on a planetary scale. The Moon's rotation is not just a celestial phenomenon, it's a crucial component of life on Earth. With the Moon's rotation halted, the oceans would be thrown into utter chaos. The gravitational pull that once orchestrated the tides would falter, causing unpredictable and violent tidal waves. Coastal regions would face unprecedented flooding, and marine ecosystems would be severely disrupted. The once rhythmic dance of the tides would become a chaotic and dangerous force. The climate would also face dramatic changes. The Moon plays a crucial role in stabilizing the Earth's axial tilt. Without its steadying influence, the axial tilt could vary wildly, leading to extreme seasonal changes. Regions that once enjoyed moderate climates could experience severe weather patterns, from scorching summers to frigid winters. The delicate balance that sustains life as we know it would be upended. Humanity would be forced to adapt to these drastic changes. Coastal cities might be abandoned or fortified against the erratic tides. Agricultural practices would need to evolve to cope with the new climate extremes. Innovations in technology and infrastructure would be essential to survive in this new, unpredictable world. The resilience and ingenuity of humans would be put to the ultimate test. The Moon's role in our world is truly indispensable. It not only influences the tides and stabilizes our climate, but also inspires countless myths, legends, and scientific inquiries. The moon has been a constant companion in our night sky, guiding navigators, inspiring poets, and fueling our curiosity. Its importance extends far beyond what we can see, reminding us of the delicate interplay of forces that sustain life on Earth.